Today we are to discuss about the basic electronic unit number 1, introduction of basic electronic. Okay, I am LP Vamre presenting the lecture on a basic electronics engineering. First of all, we have to study the active and passive component. Okay, active and passive component. Passive component means it consume the energy, and active component means it supply the energy to the instrument. It is called the passive component. The passive component is resistor, LDR, thermistor, capacitor, inductor, switch, variable resistor, and transformer. The active components are BJT, JFET, MOSFET, and operational amplifier. The active device. The difference between the active device and passive device: the active device inject power to the circuit, whereas passive device are incapable of studying any energy. Active devices are capable of providing power gain. Passive devices are incompatible and providing power gain. Active devices can control the current energy flow within the circuit, whereas the passive device cannot control it. An external power is required to start the basic operation of active device, where no extra power is used for the passive device. Then we have to study the introduction of semiconductor physics. There are three types of material. One is the conductor, semiconductor, and insulator. Conductor means the material in which the conduction band and valence band are separated by are overlapping to each other is called as a conductor. Semiconductor means the conduction band and valence band are separated by a small energy gap. This is called as a semiconductor. And insulator, the conductor and the valence band and conduction bar are separated by large energy gap. The gap between the conductor is very high. The conductivity is very high. The semiconductor conductivity is medium, and the insulator's conductivity is negligible. Then there are two types of semiconductor. One is the intrinsic semiconductor, and second is the extrinsic semiconductor. The intrinsic semiconductor is a pure form of semiconductor. The extrinsic semiconductor are divided into two types. One is the P-type semiconductor, and second is the N-type semiconductor. The intrinsic semiconductor, the doping level, and extrinsic semiconductor. The intrinsic semiconductor, if trivalent impurity is added in a intrinsic semiconductor, then form the P-type semiconductor. When pentavalent impurity is added in a intrinsic semiconductor, then form the N-type semiconductor. Then first of all, we have to study the N-type semiconductor. If pentavalent impurity is added in a pure semiconductor, then form the N-type semiconductor. The pentavalent impurity are called as a donor impurity. The pentavalent impurity are arsenic, phosphorus, antimony, and bismuth. Suppose we have to consider the silicon crystal containing antimony atom at the central position. The pentavalent contains 5 valence electrons. Out of 5 valence electrons, 4 electrons are forming the covalent bond by sharing 1 electron to the neighboring atom. The 1 electron is an extra electron. This is called as a donor impurity. And then next is the P-type semiconductor. When trivalent impurity, this is also called as the acceptor impurity. The trivalent impurity is added in a pure semiconductor, then form the P-type semiconductor. The trivalent impurity are boron, indium, and gallium. Suppose we have to consider the pure semiconductor is silicon. In this silicon, we have to impure a boron atom. Consider a silicon crystal containing boron atom at the central position. Boron atom contain the 3 valence electron. Out of 3 valence electron, only 3 covalent bond will be completed, but last covalent bond is incomplete. Then boron will be seek the 1 electron from the surrounding and complete their 4th covalent band, and hence the p-type semiconductor is called as the acceptor impurity, because he will be accept the electron from the surrounding. It is called as a acceptor impurity. Then p-n junction. What is the p-n junction? When p-type material and n-type material are electrically combined together, then form the p-n junction. In this figure, we have to consider the p region contain number of holes and n region contain the number of electrons are randomly moved in a certain position. This is called as the p-n junction. The p-n junction is also called as a diode. Why diode? Because di means 2, OD means electrode. This is a 2 electrode device. The name of the electrode is anode and cathode. P-type contain anode and n-type contain a cathode. This is the junction. Please see here the yellow line shown in our PPT. This is called as the junction. Means p-type material and n-type material are combination point is called as a p-n junction. At the instant of junction, formation free electron in the n region near a p-n junction begin a diffuse across the junction and fall into holes near a junction and p region. This is a barrier potential. The barrier potential developed in between p region and n region. This is called the depletion layer. For every electron that diffuse across the junction and combine with the hole, positive charge is left in the n region and negative charge created in a p region, forming the barrier potential. This action contains until the voltage of barrier repels the further diffusion. Then the diode will be worked in a 2 condition. One is the forward bias condition and second is the reverse bias condition. What is the forward bias condition? When p-type material is connected to positive terminal battery and n-type material is connected to negative terminal battery, and then hence we can say that the diode is in forward bias condition. In forward bias condition, the large amount of current can be flowing through the diode. In forward bias condition, the width of deflection layer will be decreases. Means current can be flowing in a forward bias condition. Then reverse bias condition, when p-type material is connected to negative terminal battery and n-type material is connected to positive terminal battery, and hence we can say that the diode is in reverse bias condition. In reverse bias condition, the width of deflection layer is increases, and hence no current can be flowing in reverse bias condition, and hence in reverse bias condition the diode acts as a open switch. In forward bias condition, the diode acts as a closed switch. Please see the figure. In this figure, we can say that in forward bias condition, the deflection layer is very small. In reverse bias condition, the deflection layer is very large. That means we can say that no current can be flowing in a reverse bias condition, and current can be flowing, or current will be flowing in a forward bias condition. Then voltage current characteristic of the diode, means this is called as the VI characteristic of the diode. We see here this is the voltage versus current graph of the diode. First of all, we have to study the forward bias condition. In x-axis we have to consider the forward voltage, and y-axis we have to consider the forward current and reverse voltage. You can see that in forward bias condition at 0.7 the diode will be current take place through the diode at 0.7 voltage, or rapid rise of current flowing through the diode at 0.7 voltage, because if we are to give the diode voltage is 0 volt, 1 volt, 0.1 volt, 0.2 volt, up to 0.7 volt diode can't be on. After 0.7 volt diode sudden rise of current take place through the diode, means the diode requires minimum 0.6 to 0.7 voltage for the operation. This is called as a barrier potential. And we can see that reverse bias graph. In reverse bias condition, no current can be flowing through the diode, just a small amount of current flowing through the diode. This is called the reverse breakdown current. This is the negligible amount of current flowing in the reverse bias condition. This is also called as a microampere. Then current in a p-n junction. You see here, this is the difference diagram for the how to current will be flowing through the diode. First of all, consider the p-type metal and n-type metal. The arrow will be showing in opposite direction. At that time, the current will be flow in positive to negative direction, and next is a negative to positive direction. Then isolated junction, followed by junction, and reverse by junction. This is a diode current equation. This is called as a diode current equation. This is ID is equal to Is into e raised to q Vd neta Vt minus 1, where ID and Vd is the diode current and voltage respectively. Q is the charge on electron. N is the identity factor. N is 1 for the silicon and germanium diode, and N is equal to for GaAs and IST means LED, etc. Generally, N is considered as 1 for silicon general diode or voltage diode. K is the Boltzmann constant. T is the temperature in Kelvin. Kt upon Q is also known as VTS. This is thermal voltage at 300 Kelvin or room temperature is 25.9 millivolt. We have to consider. Where Vd is negative, Id is equal to minus Is. Where Vd is positive, Id is equal to minus Is e raised to 2 Vd upon neta Kt. Diode as a switch. The application of diode is a diode as a switch. First of all, we have to consider diode as a switch means we have to consider only on switch and off switch. If the diode is connected in third bias condition, at that time current can be flowing through the diode is take place. This is called as a forward bias junction. Means diode will be in a forward bias condition. At that time, the diode is acts as a closed switch. If the diode is connected in reverse bias condition, no current can be flowing through the diode. At that time, we can say that diode is in reverse bias condition. Means using this property of this diode, we can use the diode as a switch in digital electronics. If we are to require the on switch and off switch for the some millisecond, at that time you have to use a diode as a switch. This is the basic diagram of this current going to the diode. This is the rectifier. There are three types of rectifier: half-wave rectifier, full-wave rectifier. This is another application of the diode. There are two types of application of the diode. One is a diode as a switch, and second is a rectifier. The rectifier means it converts AC into pulsating AC. The rectifier is a very important application of the diode for use in any DC circuit. First DC power supply component is a rectifier, because this is a convert the AC circuit or AC voltage into pulsating DC. Then rectifier circuit we can study in the next lecture. Thank you.